Good evening, all of you. How are you, Kaushik, Mohammed, Gautam, Kamya, Mummal, Harshil, Chaitanya, Sriram, Sairam, all of you are fine? Yes, friends. So what we are going to discuss in today's class? All of you are fine or more than fine? I am fine, thank you, Gautam. And all of you are full of energy to run the class, or you had the previous classes also? Yes, friends? Okay, you are more than fine. I am fine, Kiran. So this is your first class, or you had any other class before that? Physics, chemistry, mathematics, or biology? Oh, this is the first class. Okay, very good. So all of you are again full with energy, so we can solve many questions. Yes? So you have enough energy to get exhausted in this class again. So friends, in this particular class, we will try to understand about the concept that is Pythagoras theorem. Right? We'll try to prove Pythagoras theorem and we'll try to see its applications. So many of you would be already knowing, right? Okay, so Harmit already had one hour class. Okay, fine. So for some of you it is, for most of you it is the first class, and for some of you it is the second class or maybe the third class, right? Okay. Okay, fine, Harmit. I got the point. So friends, Pythagoras theorem and its applications. So anyone can discuss about what is really Pythagoras theorem? Yes, friends. Yes, it is applicable in the right angle triangles. Absolutely correct. Very good, Kaushik. A square equals B square plus C square. Absolutely. So now many of you have the idea about Pythagoras theorem. So hypotenuse square is equal to the other side's square. Okay, fine. Very good. So can you prove it also? Yes, friends. So now let us try to, first of all, before that, let us try to understand one related topic, right? Then we'll come back to the Pythagoras theorem. So all of you just try to read down this statement, which says, if a perpendicular is drawn from the vertex of the right angle of a triangle to the hypotenuse, then the triangle on the both sides of the perpendicular are similar to the whole triangle and to each other, right? So all of you have understood this statement or not? What it says. The first and important point is to understand this statement. Then we will jump on to have the answer or the proof if we want. Right? Yes, friends. Yes, Sriram. What happened? So friends, anyone having any doubt in understanding this statement? We have a right angle triangle, and from the vertex of the right angle, if you try to draw the perpendicular on the opposite side, then there will be two small triangles. They will be similar to each other and to the bigger triangle, that is the right angle triangle. All of you agree with this? So can you prove it? Yes, friends. So this is very simple to prove. Okay, Gautam. So this is the triangle, right? So right angle triangle is given to us, and basically let us try to write down some details. So let us say this is A, right? Let us say this is B, and let us say this is C, and this is, let us say, D. Now it is given that we have a few points which are given, which is angle B equal to 90 degree, right? And the other angle, that is, we have BD perpendicular, that is BD perpendicular to AC, right? Which is by construction according to the question, or basically according to the theorem. Yes. So friends, now can we prove what is to be proved? Yes or no? So basically what we have to prove? We have to prove that these two triangles, which are this triangle and this triangle, both are similar to each other and also similar to the bigger triangle. Fine. So friends, we can consider any two triangles first. Let's try to consider one small triangle, and yes, absolutely, Muhammad. So let's try to consider one small triangle and the big triangle, that is triangle ABC. So let us try to consider the triangle. Sequence is also important. You have to understand the sequence is also important. So in triangle ABC and triangle, that is, let us say a triangle ABD, for example, right? Now let us try to see what are the angles that are common, that is the angles which are same, right? So LD equals LB. Okay, for angle D you are trying to say, okay, fine, Muhammad, absolutely. So I can simply say that angle B equals angle D, that is nothing but equal to angle D, which is 90 degrees. Absolutely correct. Very good, Sriram. Angle C is common. Angle C is common or angle A is common? We are taking up a triangle ABC and triangle ABD. So angle A will be common, right? Okay, so angle A equals angle A, which is, we will write down the reason that it is common. So now we have 2 points which are sufficient to prove these two triangles are similar. So friends, try to name the triangle, try to write the correct sequence of the triangle which are similar. So we can say, if I write it down, the first I have triangle ABC. So it should be similar to which triangle? ABD. So try to understand, B is equal to D. So how we can have the name of triangle? All of you just try to listen once again. So A is equal to A. So first of all, A should be there. We know that angle B of ABC is equal to D of the other triangle. So it should be D. And finally we should have C. Or basically A. Okay. So all of you just wait. So can we say AB is common? Yes, AB is common, but here we need not prove that one, right? So here we need not prove that one. So basically friends, so triangle ABC, A was equal to A, so first of all we should have A as the first term of the other triangle, right? Now secondly, B is equal to angle D. That is, angle B is equal to angle D, so ADB I should say, right? Is it correct or not? Yes friends, anyone having any doubt in this? Fine? Okay. So by which criteria I would say? Can I say by A criteria of similarity? Yes? Okay, fine. Now with this, can I directly say that I have some of the angles of these two triangles equal? That is, if I say this angle of a small triangle, what is that? That is angle ABD. Yes? Yes friends, is it not angle ABD? I will try to see why we are trying to find out this angle ABD. So angle ABD is equal to which of the angle? Angle ACB. Absolutely Manas, very good. Angle ACB. So the sequence is important, so we will have to look up at both the name of the triangles. That is ABD, then ACB. Or if you try to understand why both these angles are equal. So if your sequence is important, ABD, therefore we should have here ACB, right? Okay, fine. So we can say that this angle and this angle are both equal. Now it is very, very simple to prove the other triangles similar. So the first condition is satisfied. This is what we need to prove. The first one we have proved. And now the second is basically, so similarly we can prove the other, that is the small one and the bigger one. Any doubt in that? So let us try to prove both the triangles similar, that is the small triangles as similar triangles. As we try to consider the triangle ABD, so try to consider the triangle ABD and triangle BCD. So friends, first of all, the angle is 90 degree in both, that is angle D is equal to angle D, which is equal to 90 degree. So this is basically by construction of given part. Now what is the second angle that are equal? So here we have angle ABD, we have just now seen here, that is this one. Angle ABD is equal to angle ACB. Yes friends? Now please try to tell me if by these two statements, by AA criteria, which are the two triangles which are similar. So because here what we need to have, sequence is very important. If anyone having any doubt in the sequence, please ask. Because these are the basics. We need to have basics very, very clear. So here we have ABD similar to triangle BCD, right? So let's try to, if you want to cross check whether the sequence is correct or not, what you will do is D equal to D. So here we have D. So at the end we should have D, right? Now ABD equal to ACB. So here we have B. So here we should have C. Fine. This is how we can prove these triangles similar. Anyone having any doubt in this? Yes friends? Okay. So I will just give you once again a summary. So one part is left friends. Which one is left? We have to prove that, first of all we have proved that this triangle is similar to the bigger triangle. We have proved that. We haven't still proved that this small triangle is similar to the bigger triangle. So similarly we can prove that one also, right? So nothing new innovation in that one is required. So all of you can do this. Anyone having still any doubt in that? So please ask. Okay, fine. So I will just again give you the summary. So basically here we have this right angle triangle and this is a perpendicular BD. What we have to prove is that these two triangles are similar to each other and to the bigger triangle, right? So what we can do is you can pick up any two triangles first of all. So this triangle and the bigger triangle, and in this one we know that here it is 90 degree and here also it is 90 degree because it is given angle B equal to 90 degree. The first angle is angle A is common, so by A criteria these two can be easily proved to be similar. Similarly, by using this similarity, we have found out that this angle is equal to this angle, which will work in these two small triangles. Because one angle is already 90 degree and these two angles are again equal. So now we have two angles equal. So by A criteria, these will be nothing but similar. And also similarly, you can prove this is small triangle and the bigger triangle are also similar. And how we can prove this? D is 90, angle C is common. So anyone having any doubt in this? Yes, friends. Okay. Now let us try to read this theorem. That is the Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So all of you please help me out to prove this theorem. And at the end of the class, if there will be little time left, then I will ask you one very interesting question which is out of mathematics. Let us see how many of you can answer that, right? Okay, so before coming to that, we have to cover the Pythagoras theorem. So the more faster we cover it, and then in less time we'll reach that particular question. So in a right triangle, square of hypotenuse is equal to the sum of the squares of the other two sides. So this is what we have already said in the beginning of the class. Fine? Yes, friends? Okay. So now anyone would like to have any conclusion how we can prove this? Any one of you? So I will just provide you the hints. You will try to link up those hints and okay, and then we'll try to finally conclude that what we have. Yes, the construction. Yes, Mohammed, absolutely correct. Okay, Ellen, you are not getting the whiteboard. So here we are learning on the screen for now. So are you getting it now? Yes. Okay. So we can use the previous theorem. Comment says we can use the previous theorem. Or let us try to first of all have figure, right? This is the right angle triangle we have. Yes. So let's try to name this right angle triangle. Let us say this is A. Okay, fine. Now you are getting the slides. It's good. Let us say this is B and let us say this is C. This is nothing but AD, right? Now what we have done by construction. So first of all, angle A equal to 90 degree, which is given. Yes, friends. And the second part is by construction. This is the second part. By construction we have that is AD perpendicular to BC. Fine. AD is perpendicular to BC. Now what is the next step? Yes, friends. Okay, Raksha. So first of all, this is the second theorem that we are proving. That is the Pythagoras theorem. So what in this we have to prove that AB square plus AC square equals BC square, right? So I'll just give you the summary if we will have the time at the end of the class. So this is what we have to prove. Now please friends quickly try to give me the steps. Because many of you said in the beginning of the class itself you already know the theorem. So you should be able to give me the steps quickly. So here again the same thing. We are going to prove the sum of the triangles similar. Yes, friends. Now this is 90 degree and this is also 90 degree. Now as some of you said, we can make use of the previous theorem that we have encountered, right? Okay. So Elika, that is what we have done in the first theorem or not? This one. Yes, friends. So we can continue from this theorem itself. So that is why we are saying that let us try to consider first of all this one. So friends, here in this particular figure you have that is here we have BC as the hypotenuse. So and here we have AC as the hypotenuse. So please do not get confused in this, right? Because we have named these two figures differently. Now here ABC is similar to ADB. So from this we know about the proportions or not? Yes, friends. Shall we discuss about the proportions? So can I simply say that AB by AD, because both are similar, that is AB by AD is nothing but equal to, yes, anyone else would like to give what is that should be equal to AC by AD. Is it correct or not? Is it fine? So we'll just take those ratios which are required, right? Okay, fine. So now here we have AB by AD equals AC by AB. So this is from the first one. From the second one, that is these two, right? So all of you can notice here we have other two triangles which are also similar. Yes, friends? That is these two triangles. Now from this one we will try to understand about that is what we can get out of these two triangles. Anyone would like to help? So ABD, first of all, let us try to understand this. Here we have AB by BC. AB by BC is nothing but equal to, yes friends. So let's try to write down all the three ratios first. So AD by BC is equal to AD by BD is nothing but equal to, again we have here BD by CD. Yes. Now we can pick up any of the ratios. So first of all, we should try to think that from this, the first equation, if I cross multiply, then I get AB square equals to AC into AD. Yes or no? First of all, anyone having any doubt in this equation? Yes, friends. Okay. So similarly, can I get the other? Okay, Kiran. So here what we have done in this one, if you cross multiply, so you will get AB into AB, that is AB square. AD into AC, so that is what we have written, right? Now, try to think that first of all we need AB square, that is what we have got, yes or no friends? Because we need to have these values. Now we need anyone that is AC square or BC square. So from this, how we can get AC square or BC square? AC square or BC square? Yes friends, can we get that? So basically these are these two triangles that we have proved as similar. So instead of that we would need these two triangles. That is a smaller triangle. Which one, Manas? It is AD by BD. So AD by BD, this is what we are talking about? BD by AD. Okay, fine. So in which one of in this one you are talking about, Manas? Let us try to cross check. So AD, here we have AB by BC equals AD by BD equals BD by CD. So is there any doubt to any one of you in this? Yes, friends? Okay, fine. So friends, basically now what we have noticed from this particular fraction, we need not, that is out of this we will not get the required value or not, because what we need, we basically need AC square or BC square, but if you cross multiply in any one of these you will not get AC square or BC square. So we should try to think about other similar triangles. So please tell me here that in this one BDC and ABC are similar or not? Yes or no? Yes? So please try to tell me the sequence. So let us try to rub this. Now please try to tell me the sequence. So what is going to be the sequence of that? Yes friends, if you try to consider, that is the triangle BDC. So triangle BDC should be similar to triangle, yes, which one? Yes friends. So here triangle BDC, so here D is the right angle, so in the middle we should have B, C is common, so ABC, right? Is it fine or not? That is BDC is similar to triangle ABC, because if you try to note the angles here to verify, so here D is right angle triangle, right? So here B is right angle, here C is common, so C and C, right? Okay, fine. So from this we can get the ratio. So let's try to get those ratios. So BD by AB is equal to BC is equal to BC by, basically we have here AC is nothing but equal to, finally we have DC divided by BC. So now you will notice that here from this expression you will get what? BC square or not? Yes friends. Is it fine? That is why we should understand what are the triangles that we need to consider. Now it becomes very simple for us. From this we will get, that is BC square equals, so all of you can do it from here on, BC into AC, right? So now what is basically required here? So here it was AC square, right? Yes or no? Or basically here it was AB square. So friends, if you add both, that is this one and this one, BC square plus AB square, try to add both, you will get DC into AC plus AC into AD. Now anyone having any problem in proving the Pythagoras theorem? Now it seems to be simple now. You can take AC as common. If you take AC as common, DC plus AD will be inside the bracket. Now try to say in the figure, what is DC plus AD? So try to see here, DC plus AD is nothing but equal to AC. Yes, very good, sit down. So here we have AC. So finally AC into AC is AC square. Yes friends. So it is basically that we have BC square plus AB square is nothing but equal to AC square. Anyone having any doubt in proving this? Yes friends. Yes, we can take it to another side as well. So just try to, first of all, that is what I have said in one of the earlier classes also. We can prove all the theorems with the knowledge in hand, right? We need not have any other thing or any other concept which we have not studied. Fine, so we must always try to prove all these things. Any doubt to any one of you? Okay. Now let's try to quickly solve the examples. So solving examples is very easy. Yes, we all know concepts, so you just have to put in the values and find out the answer, right? Understanding the concept requires little time, but solving examples is very, very easy. Now all of you just try to read down this very, very simple question. Two poles are of length 4 meter and 16 meters. The distance between the foot of pole is 5 meter. Find the distance between the top of the pole. Now let us say this is AB. So AB is one pole, that is of 4 meters, right? Let us say this is CB. So CD is totally another pole of length 16 meter and distance between the poles is 5. That is very, very simple. Quickly try to tell me the final answer. Now if I say this point is E, right? So this triangle is right angle triangle. So can I simply say that the required distance AD square is nothing but equal to AE square plus DE square? Very good. 30 meters. All of you have already found it out. Very good. So A is what? 5 square plus DE. So DE is nothing but equal to 12. So 12 square. So it is nothing but equal to 25 plus 144, which is 169. So AD will be equal to nothing but 13 meters. Fine. Okay. So, okay, fine, Ellen. So, are you able to see the question? Yes, Ellen? So, I will just again, okay, fine. If you are not able to see the question, I will just again explain you what is the question. You can quickly solve in your notebook. That is, the question is, we have two poles, right? Okay, which distance we must take? So, okay, then I am just again explaining it to you. We have two poles. One is shorter one, which are 4 meters. One is longer, that is 16 meters. Distance between them is 5 meters. So this is the situation. Now, we have to find out the distance between their heights, distance between their tops, right? Now, how we can find this? Basically, here we have, yes. So, what we have to find out is AD, that is in the orange one. So here, we know that if in this right angle triangle, we can easily apply the Pythagoras theorem. We know this value, but if we get to know this value, we can easily find out this one, right? So basically here this value we can easily find out that is total 16 minus 4, because this is also equal to 4. So this will be 12. Fine. Now the situation is clear. So whenever you have these questions, so just try to understand, try to visualize the situation, right? You may be roaming around, you may see some poles. So try to just understand this kind of situation will arise. Fine. Do not just try to stick to the notebook. Try to visualize the situation. So anyone having any doubt in this? Yes, friends? Okay. So let us now again quickly try to solve one again very simple question. The lengths of the diagonal of a rhombus are 8 centimeter and 6 centimeter. Find the side of the rhombus. Yes? Very good, Raksha. Very good. Absolutely. That is what we need. So basically, if I just say this is, let us try to name the rhombus. So ABCD is the rhombus, and let us say they intersect at O. And we know one thing, that diagonals of rhombus bisect each other at 90 degrees, right? All of you agree this? Diagonals of rhombus bisect. So we have to write the reasons, right? Bisect at 90 degrees. Very good. So all of you have already given the answers. So 8 centimeter, 6 centimeter. So can I say one, this is OC is 4 and OB is 3? Yes friends, is it fine? Because total BD is, let us say 6. Let us say 6 is BD and let us say 8 is AD. So OC will be 4, it is half of it. All of you agree with this? And this is bisecting at 90 degrees. So it simply implies that the triangle BOC is right angle triangle, or basically it is a right triangle. Yes friends? Okay. So anyone having any doubt? So basically we can apply that Pythagoras theorem. So we will say so we have to write the steps. I have already told you, when the questions are very very simple, the steps become more important. So we will try to write down here, that is by Pythagoras theorem, right? So we can say that here 3 square plus 4 square equals BC square. So finally we will say that BC is equal to root 25, which is 5 meters. We have to write them units as well, because say it is centimeters. Fine? Yes, centimeters. So anyone having any doubt in this simple question? Yes friends? Okay. Now let us try to understand this question. This is again a very easy question. So in the given figure, AE is equal to 4. So let us try to write it down. AE is equal to 4. AB is equal to 3. Fine. CE is given to us as, or BC is given to us as, and we have CD as 9. Let's try to write down the units. Now we have to find out the length of DE. This is what we have to find out. So Swarangi, we are now doing the Pythagoras theorem. So if you know the definition of the Pythagoras theorem, it's okay, you can directly apply it. If you don't know, you can ask. So basically friends, what is the length of DE? First of all, tell me what is BE. Yes? Very good, Sairam, absolutely correct. We should start from BE. BE is equal to 5. Very good. So this is what we have just now covered or not? 3, 4 and 5. Yes? So you can directly write it down, but whenever you will have the question, you will have to solve this. So we are not solving this because we have just now solved it in the previous question. Now, what about CE? So we can simply say that CE is, this is what we have already done or not? CE, which is nothing but equal to root over square plus 5 square, which is nothing but equal to 30. Yes? So what is 12 square plus 5 square is 169. So 13 square is 169. All of you agree with this? Anyone having any doubt? So please ask. Any sort of any doubt why we are doing this, how we have directly written down inside the root? Yes? Because, so we will try to write down the steps. Okay, Gautam, just wait for a while. We will have to write down the steps. First of all, that is in triangle BCE. The angle B is 90 degree. We have to apply the Pythagoras theorem. According to that, BC square plus BE square equal to BCE square. So all these steps we have to write it down. Right? Okay, so first of all, try to understand what I am saying. I'll come back to the answer. Because the answer is not that important, because the answer you can easily find it out. This is a very simple question, right? So try to understand the concept. So we need not write down in the points. Okay, fine. So here, finally we can say, let us try to write down the steps in the last one. So in triangle CDE, angle C is equal to 90 degrees. So by Pythagoras theorem, we can simply say that DE square is equal to CD square plus CE square. Okay. So many of you have already given the correct answer, but still let us try to follow the steps. CD square is 13 square plus 9 square, right? Now 169 plus 81. What is the sum? So friends, please try to first of all try to tell me what is the sum. 250. Okay, very good. Absolutely correct. Right? Now 250 is what? 5 square into 10? Very good. Right? So we can say that DE is equal to nothing but under root 5 square into 10. Right? Now we can take 5 outside the root. So 5 root 10, and the unit is going to be centimeter, because it is given that these all are in centimeter. So we have to again understand, or we have to just again look up at the units as well, because units are also important. Yes friends? Now anyone having any doubt in understanding this? So these are very simple questions, but still because we are doing it for the first time. So please, anyone having any doubts, please ask, any one of you. No doubt? Shall we solve some more questions? No, Gautam, if you write it down as 5 root 10, it will be absolutely correct, right? You'll get the full marks, right? Yes, Sairam 3, 4, 5 are the Pythagoras triplets. So that is what we can again and again use directly. Fine? Okay. So friends, let us now try to understand the converse of the Pythagoras theorem. So the converse is, you can yourself predict what is the converse, because we have already covered the Pythagoras theorem. Triangle, if square of one side is equal to, every theorem has a converse, but in some cases the converse is not true, but in some cases it is true, right? Very good, Raksha, congratulations. So it's a proud moment for you and also for us. So please keep on following all these, because apart from the studies, these things are very, very important, right? So congratulations, Raksha, from the entire class to you, including me. Okay, Sairam says Junior Nehwal. Okay, fine. So sometimes, who knows, she will become more popular than Saina Nehwal. Yes, Raksha. So keep the good work going. So all the best for you in that regard. And also to other students who are pursuing the extracurricular activities and also performing good. So please, all of you, all the best for that thing, right? Because all these things are very important. So friends, okay. So let us now come back to the class, to the converse of Pythagoras theorem. So all of you know the converse, all of you can predict the converse as well. So in a triangle, if square of one side is equal to the sum of the squares of the other two sides, it is already given. Yes, Kiran, absolutely. So what is the construction? So ABD, right? So it is already given that, or ABC, let us try to say it. So let us try to say it as ABC, fine? Okay. Okay, Ellen, so there is some internet problem on your end, that it means, because the rest of the students are not facing the same problem. So what you do is please log out and log in once again, right? So now we have become used to this. Whenever we have a problem, we have to log out and log in once again, fine? So no need for me to say it again and again. All of you can understand that. So in triangle ABC, so immediately log on and log it once again, because if you do it as fast as possible so that you do not miss the rest of the class, right? Basically the concept that we are covering in the class. So in triangle ABC, it is given that AB square is equal to AC square plus BC square. Yes, friends? So again, we have to draw perpendicular, or any other construction we require in this. Yes, friends? Anyone would like to help? Or we have to form another figure? Okay, fine. So all of you are trying all your methods. Okay, but here I have one more simple method. So let us try to apply that method. Fine? Okay. So let us try to draw another triangle. Fine? So let's just first of all write it down. Here let us say this is PQR. So basically here, by construction, all of you just try to listen up. By construction, we have to draw a triangle in which PQ is equal to AC, in which QR is equal to BC. Fine? And angle Q is equal to 90 degrees. This is by construction, because we can draw such a triangle. This is very simple, right? Because we won't face any difficulty in having such a triangle. A right angle triangle in which PQ equals AC and BC equals QR. Now it will be very, very simple to prove that angle C is also 90 degrees. You don't have to. In fact, they will be congruent, Raksha. We can prove them as congruent. Try to understand. First of all, what is this? Try to understand, this is what we have been given. Try to understand this. This is what we have been given, right? By construction, can I write it down? This equation becomes, all of you just try to listen up. This equation becomes AB square equals PQ square plus In place of BC, let us write down RQ square. Try to understand this part. What we have done is, we need AC is equal to PQ. So try to substitute AC equal to PQ. We need BC equal to QR. Try to substitute BC equal to QR. So it is this equation we have got. Anyone having any doubt till here? Any one of you? Okay. Now, can any one of you tell me the next step quickly? Yes, friends. The next step. PR. Very good, Ellen. Absolutely correct. Because this is a right angle triangle. So we have PR square equals plus QR square. Right? Now, from these two equations, let us say this is 2, let us say this is 3. We can directly say that AB equals PR. Yes, friends? So now what we have covered is that this third side is also equal. Okay. So Kiran, just try to see here. On the right hand side, what we have? PQ square plus QR square. And similarly, here on the right hand side, we have PQ square plus QR square. What does this mean? It simply means AB square equals to PR square. AB square equals PR square. So it simply implies that AB equals to PR. Okay, fine. And if still anyone having any doubt, please ask. So friends, by SSS, can I say both these two triangles are congruent? That is by, because both two sides are same by construction and one side we have proved as equal. Right? So we can say that triangle ACB is congruent to triangle PQR. Now by CPCT we can say angle C equal to angle Q, and we know that angle Q is 90 degrees. Right? So is it proved or not? Yes, friends. So Converse is also proved. So each and every theorem, all the properties are having proofs. So we just have to think how to prove those theorems and properties. And one more thing is, if you want to be really conceptually strong, so please try to prove the theorems, right? Try to prove the theorems yourself. This is very important. Yes, Gautam, please ask if you have any doubt. Or let's try to solve some examples if you don't have any doubt. Yes, friends. So Gautam was, yes, Gautam, is your doubt clear? Okay. Okay, fine. So you are trying to say, is there any other method? So Gautam, in geometry you have many methods. It depends upon how you think, right? So there are other methods also. What you can say is, instead of drawing this, because we have to look up at the simplest of the ways. Fine. There may be other methods, longer methods. Fine. So we just have to look up at the simplest ways possible. Because what we just want to solve the question as quickly as possible and get back to the next question, right? We have to finish the question paper as early as possible and then go back home. So we just have to find out those ways. So friends, let us now try to understand some examples. Let ABC be a triangle with sides AB equal to 4, BC equal to 3 and CA equal to 5. All of you just try to understand. So let us try to draw this triangle first. Let us try to have this triangle. Right? So all of you would like to answer this question. We have already done it many times. So here what we have, this is A, this is B, this is C. AC is given as 5, BC is given as 3, AB is given as 4. So can we say it is a right angle triangle? Absolutely correct. Very good. So this is how, we have already utilized into one theorem and one example, right? So why we can say this is a right angle triangle? Because here we have AB square plus BC square is nothing but equal to 4 square plus D square, that is nothing but equal to 25, which is equal to AC square, right? Yes. So anyone of you having any doubt? No, Hermit, there is very less probability of getting such a question in the examination. This is just to introduce you that basically you need not be given each and everything in sequence, right? You need not be given each and everything in sequence. You would be given 3, 4, 5, because many of the students get confused that whether if AB becomes 3 or BC becomes 4, right? So what is the condition, is the situation will change? So all these things are, will the situation change? So all these things are important. Okay. So this question most probably this question will not come since this is such a simple question. Fine. So friends, there is the basically important part is basically we try not to set up the expectations, right? That is, we need, if this question will come, I will do, this question will come, I will do. Just be prepared for each and every question. Fine? Be prepared for each and every question. Okay, so yes, Kaushik, you are correct. This can happen. Okay, fine. So all of you, any doubt in this question? So you don't have any doubt, I know that. So let us try to proceed on to question. So in the given figure, a quadrilateral PQRS is shown such that the angle we have PQRS 90 degree. If we have PS square equals PQ square plus QR square plus RS square, and find the measure of angle PRS. And this is also one of the very simple examples. This question can be asked, right? This is a very simple question, but still it can be asked. So friends, please quickly tell me the angle. So we have to find out the angle PRS. Very good. So all of you are just now marking it like 90 degrees because we are studying the Pythagoras theorem, or you have solved it? Yes? Okay, fine. So basically, if I apply the Pythagoras theorem in triangle PQR, then what I can infer from this, I can directly say that PQ square plus QR square is nothing but PR square, right or not? Yes, friends? So that is what I am explaining the reason, Gautam. So we will not simply say that it seems to be right angle, so we will say it is right angle, right? So is it clear to you that PQ square plus PQ square plus QR square equals PR square by the Pythagoras theorem in this triangle PQR? Yes? In triangle PQR, apply the Pythagoras theorem. Now we can rewrite the expression given PS square equals PR square plus simply RS square. So just try to understand, in this one we have been given that PS square is equal to this square plus this square. So we know that whenever we have PS square, so the angle opposite to this side is the right angle. Yes or no? Are you getting this point? Yes, Harshil, absolutely. Anyone having any doubt now? Any one of you? Yes, friends. Okay, Kamya. So Kamya, just try to understand, this is the thing that we have been given, and we have been given that angle Q is equal to 90 degrees. So we can apply the Pythagoras theorem. PR square equal to PQ square plus QR square, right? Now you see in this particular equation we have PQ square plus QR square already. So we can replace this by PR square because PR square equal to this one. After replacing it, you will get PS square equal to PR square and remaining is RS square. Now look in this triangle. In this triangle PRS, you have already proved this, that is PS square equals PR square plus PR square plus SR square, right? We know that if here we have this biggest length of, or basically the largest side, the angle opposite to that will be the angle of 90 degrees, right? Okay, friends. So let us now quickly solve this. Again, this question can also be asked in the examination. This is a good question, but a simple question again. So in acute angle triangle PQR, if PS is perpendicular to QR, so all of you just try to, in acute angle triangle PQR, PS is perpendicular to, so PQR it is, right? And PS is perpendicular to QR. This is what we have given, right? Yes, Raksha. I have marked the points. Now, what I have been given is, we have to prove that so this is the right angle triangle, all of you agree? Yes, friends? So now this is very, very simple to prove. That is PR square equal to PQ square plus QR square minus this term. So just look at the figure. You can yourself think how it can be proved. Yes, friends? Try to understand it. So anyone would like to give any hint? So what I want from you is, please try to tell me the initial step, right? So no, we need not prove any two triangles similar. 90 degrees Raksha, angle Q is less than 90 degrees because we have acute angled triangle PQR. So any one of you would like to give any hint? PQ square equals QS, absolutely Kamya, very good. And PR square equals, very good Abhinav. So we can have both these equations or not. Yes friends. So if I say that in triangle PQS and triangle PSR, PR equal to PQ. So can we have not been given anything like that, PR equal to PQ. So it seems to be in the figure, but it is not, because it is not given in the question. So one more important point here, that is, please do not assume anything from your own. Whatever is not given, right? Okay, fine. Okay, so friends, in this one, what we can have is, we should try to understand both are right angle triangles, right? So we can say that PQ square equals PS square plus QS square, right? And similarly we can say PR square equals PS square plus SR square. Now we have these two equations. So can I subtract the equations? Yes friends? That is 2 minus 1. So if I subtract the equations, PS and PS will get cancelled out. PS square and PS square will get cancelled out. Right? Because both are common in both. The PS square is common in both the equations. Now I would simply have PR square minus PQ square equals RS square minus QS square. This will be the equation. From this, try to get out this. Yes, friend, now it is. Okay, Kiran. So, how you can know whether we have to add or subtract? Try to understand the less number of variables you will have in the equations, because what do you need? Do you want to have more and more number of terms or less and less number of terms? Yes? Less number of terms, so we want to eliminate some of the terms. So if you subtract, so PS square and PS square will get subtracted. That is, this will get reduced. That is why, right? Okay. But here if it would have been minus PS square, then we would have added both the equations. All of you are getting this? If here it would have been minus PS square, then we would have added both the equations to get the terms reduced. Now friends, please from this one try to find it out. Yes, this is the elimination method, Harshil, absolutely correct. What happened? Yes friends. Okay, so I think I have missed some of the joke. Okay, now let's come back to this equation. So P square minus PQ square. Here we have RS square minus QS square. Fine. So friends, let us try to keep PR square on the left hand side only. Right? So PR square equals PQ square plus RS square minus QS square. Yes friends, is it fine now? Okay. So anyone who have arrived at the final equation or not? Yes Harshil? Muhammad? Any one of you? What should be the next step? Try to understand. We are approaching the equation. If you try to see, we have got PR square, we have got PQ square, we have got PQ square. So you have to modify these terms now. Right? Try to understand. So we need to have, okay. So what we need to have change? We need to change some of the lengths. RS square, try to understand, or QS square. You can change any one of them. Okay. So can I say, all of you just try to understand, can I write down RS is equal to nothing but, RS is nothing but equal to QR minus SR? Or QR minus QS? Yes? So it is basically, RS is nothing but QR minus QS. Yes, Raksha, absolutely. So let us try to correct this first. So anyone having any doubt in this? QR minus QS. So just substitute in this equation, then you will get what is required. This is very simple. So RS, try to substitute QR minus RS square. So let's try to write down here itself. Fine. QR minus QS square minus QS square. Now just try to expand the terms. You will find some of the terms will get reduced. So then you will get what you require. Plus A square, that is QR square, plus B square, that is QS square, minus twice of AB, QR into QS. And finally here we have minus QS square. So this will get cancelled out and finally you get this way. Right? So this is what we have got. Hence proof. Anyone having any doubt? So PQ square plus QR square minus 2Q into QS. Any one of you? Okay, fine. So can we take A square minus B square? Yes, you can also take A square minus B square. Absolutely correct. But if you take RS plus, here if you have RS plus QS, that will come out to be equal to QR. Very good. And secondly, you will have RS minus QS. So what you will do of that? RS minus QS. You will not be able to modify this. Then you will have to again substitute in place of RS, right? So what you can do is you can directly substitute here. So you will get the answer. Okay, fine. So in this question, angle Q is given 90 degrees. So angle Q is not 90 degrees, Saira, but it is less than 90 degrees. Right? It is given that it is less than 90 degrees. Okay, friends. So all of you now will solve one similar example. Right? All of you will solve this similar example. All of you can solve this? Yes or no, friends? First of all, tell me this. So acute angles means angles which are less than 90 degrees, right? That are acute angles. 70, 80, 20, 0, all these are acute angles. So all of you can solve this question or not? Or I will give you this question as a homework. So this is a similar question. Yes, friends. Here it is greater than 90 degrees. So you will find there is not any much of a difference in both the questions, right? So here we have triangle PQR. So this is, let us say, triangle PQ and R, right? And PS is perpendicular to QR. Similar question it is. Fine. Now, but here what you will have to think, you will have to think what you have to substitute. Are you trying to get this point? Yes, friends. So I will just write down the equation, or basically PS square. We can simply say that in both the triangles, PS square equal to PS square or not, right? So I am doing it a little way. You can also find out the equation and then try to subtract, or what you can say is PS square equals PS square, and PS square in the one triangle, let's say in this triangle, is PR square minus RS square, right? In this triangle, PS square is nothing but PQ square minus QS square. Now we need PR square. So keep PR square on the left hand side. Let us try to have other thing on the right hand side. So PQ square plus RS square minus QS square. Fine? Any doubt to any one of you? Now just try to eliminate or just try to understand. You need QR into QS. Right? You need QR into QS. So try to substitute here again. What is RS? Same question it is. Similar question. What is RS? What is QS? Yes, friends. So first of all, tell me, all of you can do this or not? Yes or no? All of you can do this? Okay. So shall we solve the next example? QR minus. Okay, fine. So what you can do is, you can have QS square, you can substitute in place of QS square. So what is QS square? QS square is QR minus QS. QR minus RS. Right? Fine? So here negative minus 2AB and minus here, so it will become plus 2AB. That is why here plus 2AB is coming. So anyone having any doubt, all of you can solve this or not? Just substitute this one, you will get the final answer. No need to worry in that. Okay. Let us try to solve the last example, and after that I will ask you that question. So in the given figure, angle B is equal to 90 degrees, while L, M, N are the points of trisection of the side BC. Then we have to prove this, right? So in such questions, what I would suggest to all of you is to pick up any one of the sides, whether the right hand side or the left hand side, right? Try to substitute the values on both the sides and then try to compare. Are you getting the point? Yes, friends. So basically, now you will understand it. Here, this is the point of trisection, that is L and M. So this is one of the very simple question, right? So if this is the point of trisection, the L, M, N are the point of trisection, can I simply say this is X, this is also X, and this is also X? So now is it not simple? It becomes very, very easy. So just try to understand. Try to first of all look up at the left hand side. Right? Take the left hand side. 9AL square. What is AL square? Yes, friends. Is it not equal to AB square minus X square? Yes? Fine. Is it correct? So now just try to see, yes, it will be plus, absolutely. So here we will have AB square plus X square. What is 9AM square? Yes, Sairam, absolutely correct. What is 9AM square? It is nothing but equal to AB square plus twice of X square. Yes, friends? That is 4X square. Is it fine? Anyone having any doubt, please ask. And what is AC square? So AC square is, again, here we have AB square plus 3 of, okay fine Raksha, I will again explain you. So let's try to understand the last part. AC square, right? So AC square is in the bigger triangle. All these are the right angle triangle or not? All these are nothing but the right angle triangle, because right angle is at angle B. So if you try to look up at the triangle ACB, if you look up at the triangle ACB, so AC square equal to AB square plus BC square. What is BC? BC is X plus X plus X, because this is the point of trisection, right? So try to understand. So 3X is equal to 9X square. Fine? Anyone having any doubt in this? So finally you will have 9 plus 9, 18, 18 plus 9, 1, 19 AB square. Finally, what about X? Yes, friends. What about X? X will be 9 plus 36 plus 9. Yes or no? So it is 9 plus 36 plus 9. So please tell me the second term. So 19 AB square plus what is the second term? 45. Gautam says 45. Let me write down here 45. X square. Try to consider what is on the right hand side. On right hand side, what is there? 19 AB square plus BC 6 into BC square. What is BC? 3X whole square. It is nothing but 19 AB square plus 6 into 9X square. So is it 45 or 54? Yes, friends. So try to add. So let me add here. So all of you are now giving me the wrong answer as misguiding me. So 9 plus 9 plus 36. 36 plus 9 is what we have? 45. 45 plus 9 is 54. So here we should have 54, not 45. And here we have, okay. So left hand side, okay, Raksha, I will again explain the left hand side. So 9AB square plus 45. 19AB square plus 45 or 54 here. 54X square. So now both same. This is what we have proved. We simply say hence proved. Right? So this is the approach in such questions. Now Raksha, basically what we are trying to do is first of all look up in the triangle ABL, right? In triangle ABL. AL square is what? AL square is AB square plus X square. That is what we have written. AB square in place of AL square we have written AB square plus X square. Now look up in the triangle ABM. In triangle ABM, AM square equals BM square plus AB square. So it is AB square plus BM square is what? 2X whole square. That is 4X square. Now is the point clear? Similarly for the third one. Yes, friends? Okay, so anyone having any doubt? Any one of you? No doubt to any one of you? Okay, fine. So now shall I ask you the question? Yes, friends? All of you are ready for it? Okay. So first of all, so this is a very simple and general question, right? So please tell me how many of you know what are fundamental duties? Yes? How many of you know what are fundamental duties? Yes, friends? Okay. So can you tell me some of the fundamental duties? So whenever you open up the first page of the NCERT, they will find the fundamental duties, right? So nobody has looked up at the first page. Yes? Yes, friends? Why they are given? So many of you would have noticed the image of Gandhiji, and there also by the side of that there are some fundamental duties written. Yes? Okay, so you have noticed the image but you haven't read. So not in maths, this is a general question. Very good, Shriram. Shriram knows one of the fundamental duties. So it is important for us to know what are the fundamental duties, right? Okay. Yes, Harmi, that wasn't a riddle. So basically, apart from the riddles, human rights, absolutely. So out of that, there is one fundamental duty that I would like to share. Fine. Let us see what is that fundamental duty. This is that fundamental duty. That is the second last, which says to strive towards excellence in all spheres of individual and collective activity, so that nation constantly rises to higher levels of endeavor and achievements. So what does this mean? It simply means it is our responsibility. It is our responsibility to excel in the fields, in all the spheres that we want. Right? For example, in academics, for you. Are you getting the point? Yes, Anand, you are correct. So that is important for us. At this point of time, what does this mean to you? This simply means just try to understand, study hard, try to focus on the extracurricular activities, right? So basically just form yourself as a responsible individual, right? Yes, sports also, absolutely. So that is what it means for you as a student. So that because each and everything is corrective. So if you will do good work, the other student will do the good work, and similarly if all the people will do the good work, right? So then it simply means that here we have basically the whole nation should progress, right? Yes, friends. Okay, so Manas, in the next class I will surely give you the riddle. And one more important point, friends, I would like to share that on Friday and Saturday I will not be available to take the class for you. So Sanjeev sir is taking class on Friday and Saturday, right? Okay. And one more important point. So someone of you might be thinking that why there is a fundamental duty for me only, why there is for the students only, right? So some of you might be thinking in that perspective. Yes or no? Yes, friends? Okay. So Sairam says Sanjeev Kapoor. Okay, Sairam. So Sanjeev sir will give the introduction. Yes. So you have seen the classes or not? Okay, Sairam already have a riddle. Okay, friends. So I would just like to tell you that, okay, we know why always L1. L1 is a badge. So friends, please, it is not always that we will always discuss the riddles and all. Fine. So we should understand some basic and important things also in the class. So there should be a mixture of all the things. Fine. Okay, friends. So again in the next class, so I will not be available. So Sanjeev sir will take the class. Friends, so please try to practice more and more. So Sairam has a riddle. All of you please note down the riddle so that we can discuss that riddle in the next class. Okay, friends. So friends, all of you please take care. Try to understand the concepts. Try to practice more. And till then, I will come back. All of you, I wish that you will practice a lot. Fine. All of you will practice a lot. All of you will maintain the rhythm. Fine. So we'll meet up on the next Monday. Till then, friends. So on Friday and Saturday I will not be available, right? So till then, friends, bye bye and take care and practice the questions that we have been discussing in the class. Okay, friends. Bye bye.